Hey y'all, today we're going to talk about a different type of quadrilateral, different sort of family of quadrilaterals, and that are the trapezoids. So trapezoids are not parallelograms, but they do have four sides. So a trapezoid is a quadrilateral that has only one pair of parallel sides. A parallelogram had both pairs of opposite sides parallel. In a quadrilateral, or a trapezoid, sorry, there's only one pair of parallel sides, and that's this one, these two right here. They're called bases, so we can call this base 1 and call this base 2. We also call these base angles, so these angles are base angles associated with base 2. These angles are base angles associated with base 1. Now, a trapezoid doesn't always have to have its parallel sides on the top and the bottom. We can shift it like this, and you can see the bases are now on the left and right. We can turn it, flip it upside down. Okay, so a trapezoid is not always in this orientation, but this is just the example I chose. We're going to talk specifically about isosceles trapezoids. That word isosceles is a word we used earlier in the year when we talked about isosceles triangles. And in an isosceles triangle, we had two congruent sides. And that's the case here in a trapezoid, an isosceles trapezoid. So the legs are congruent. The legs are the two sides that are not parallel. So for example, in this guy down here, these are my parallel bases. If this is an isosceles trapezoid, these two legs, the ones that are not parallel, are congruent, which means they're the same length. Also, in an isosceles trapezoid, if we draw the diagonals, those diagonals are congruent. You could probably notice by the way I drew them, they're not perfectly straight, but you can see that they don't bisect each other, but we do know that they are both the same length in total. And then if I look at this one, there's one base, there's another, they're the parallel sides. The two pairs of base angles are congruent to each other. So the angles associated with this base are both the same measure, and the angles associated with this base are both the same measure. So these two are the same, these two are the same. All four of these angles will add up to 360 degrees. And the pairs of opposite base angles, so I'll just choose these two, those two opposite base angles, those will add up to 180. So 180 and 180 makes 360. So that was quite a bit of information, but let's do a couple examples together. In this one here, this isosceles trapezoid, even if I didn't call it an isosceles trapezoid, I would know it was one because those two sides are congruent and these two bases are parallel. I want to find these angles. So the base angles for one base are congruent, so that makes angle 1 58 degrees. These opposite base angles are supplementary, so I can find angle 2 by doing 180 minus 58, which is going to tell me that angle 2 is 122 degrees, and therefore angle 3 is also 122 degrees. We can use that same idea over here. Again, I don't need to know that it's an isosceles trapezoid from the words. I can see that it is one because the sides are congruent. And that makes these two angles associated with this base, and they should be the same. So 117 should be equal to 3n. So we can get that n is 39 degrees. So go ahead here and use the information I just gave you, use the examples we just did, pause the video, please press pause, and try these on your own. So again, in both of these examples, we're told that they're isosceles trapezoids, but we can determine that on our own because we're shown that the legs are congruent. So here, my base is on the right. This angle and angle 1 are the same because base angles are congruent. Opposite base angles are supplementary, so these two should add to 180. So I can get the measure of angle 2 by doing 180 minus 109. That means that angle 2 is 71 degrees. And angle 3 and angle 2 are congruent because they're base angles of the same base, so 3 is also 71 degrees. Here, just like in the example we did together, I have two angles on the same base. Those angles should be equal to each other. And now I just have to do some algebra to find n. And I get that n is 9. So there's one more special idea that we'll talk about for trapezoids, and this is for any trapezoid, so not just isosceles trapezoids, even though we've been talking about them most of this lesson. This will work for any trapezoid. We're going to talk about the midsegment. So that is a segment that goes from the middle of one leg to the middle of the other. So that is the midpoints of those legs. So if I have a segment like GH that starts at one midpoint of a leg and goes to the other midpoint of the leg, it's called a midsegment. And we can get the length of the midsegment by basically taking the average of the two bases. So if I do base 1, we'll call FE, or I'm just going to call it base 1. And we'll call this base 2. The length of my midsegment is equal to base 1 plus base 2 all divided by 2. So if I know how long these two bases are, I can add them together and divide by 2, and that will give me the length of the midsegment of the trapezoid. So I'll do an example here. I have the two bases and I have the midsegment. My midsegment should be equal to my two bases added. You could even say B1 plus B2 and then divided by 2. So my midsegment is 3x minus 6. One of my bases is 25. The other one is 2x minus 1. So I'm just plugging things in where they belong in the formula. In order to get rid of the 2, I'm going to create this to be a proportion. And I can cross multiply. This 2 is going to be multiplied by everything in here. So 2 times 3x gives me 6x minus 2 times 6 is 12. And then when I multiply 1 times all of that, it just stays the same. So now I can just continue and keep solving this equation. 25 minus 1 gives us 24 plus 2x. I'll subtract 2x from both sides. Add 12 to both sides. And finally, I'll divide by 4, getting x to be 9. So that gives us x. That means the mid-segment is 3 times 9 minus 6, which is 21. So please pause here, use the information you just got, find x, knowing that GH is a mid-segment. So I always start with the formula. The mid-segment is base 1 plus base 2 over 2. Doesn't matter which one's base 1, which one's base 2, but my mid-segment matters. That's 4x plus 1. I'll make 6x minus 2 base 1 plus 10, which is base 2. Make that into a proportion. 2 times 4x is 8x. 2 times 1 is 2. This all stays the same. And then you can continue solving. And I'm going to get x to be 3. Want to make sure you can see all this. So we are kind of around the middle of the year. We're past the midway point, actually. So let me just give you a reminder that in order for this situation to work, when I ask you to do these problems, I need you to do them. It's okay if you get them wrong. Mistakes are okay. That's why we'll discuss them, and you can fix those mistakes. I'm sure of it. So do these two problems, and we'll discuss them in class.